let's get started. We have a super exciting session today, a lot of signups, and I think people are also filtering in. So I'm very excited to help introduce my friend, Jason, who's been working on a lot of just the combination of Pydantic along with OpenAI like function calls, and seeing what you can do with that basically, and seeing how you can move beyond kind of traditional prompt engineering with strings and formatting to basically treating everything as models and objects, and using that for both the prompting piece and also the structured data extraction. So he could definitely express this better than I can. So without further ado, I'll turn it over to him.
Can everyone hear me and see my screen?
Yep.
Cool. So I'll give a little bit of context. So I would say maybe a month ago, OpenAI released the function calling capabilities. And what that really meant for us was that we were able to do structured extraction a little bit better. The goal was to do API calls, but really a lot of people have a hard time getting JSON out of their language models. And what function calls really helped with was to actually give us some instructions on how we should actually structure this data. And so my goal today is to kind of go over a couple of things, right? So one, it's just talking about like why Pydantic is useful, how we blend this into prompting. Then I'll go over some examples in my library and then sort of what I've learned from those experiments. And then lastly, I'll talk about some of the things I'm thinking about for the future. And the idea really is, by using these kind of structures, we get to go back to regular programming practices rather than having to think of like LLMs as just magic that takes text and turns to text. So if everyone's, I don't know how much familiarity people have with Pydantic, but Pydantic is basically a data validation and management library. And the nice thing about this is that it basically uses really traditional Python type annotations to get us a bunch of new capabilities around validation, serialization, and deserialization. And then OpenAI function calls is a way of effectively just giving instructions on how to output the data in JSON. And they got this data from fine-tuning the GPT-4 plugin OpenAI JSON schema calls. But the idea here is that we can do a lot more. And the reason why this has been really nice is because the Pydantic model abstraction provides sort of a code-based way of defining prompts. And the JSON serialization, deserialization schema stuff is kind of handled behind the scenes. And because we do this deserialization into Pydantic, we get a lot of really nice qualities around development. So things like having types, autocomplete, and IDE support. And because many of the tools that in the Python ecosystem already use Pydantic, there's really cool ways that we can blend in how our language model outputs interact with the rest of our ecosystem. And then lastly, I guess one thing that people may not have looked at is Pydantic's roadmap. They're actually coming out with a bunch of really interesting observability tools and product catalog tools that would actually make language models even easier to use. And so if Jerry asks me about this later in the presentation, I'm happy to talk about that as well. So before a function calling, you kind of just had to ask really nicely the LLM to get a structured data back out. You would sort of just ask for JSON, no comments, only include the comments in the markdown code. And a lot of different language models didn't actually do that very well. So GPT-4 did, but things like Bard and Claude still struggled with this kind of extraction. But now that we have function calling, which is effectively just a fine tune to get us JSON out, we're able to pass in an array of JSON that you see here. So we have an extract user, it has a description, there's a parameter, the parameters are properties, the properties has a name, and the name has types. And then sort of we get a lot of information in this definition, and then we can send that to language model. And because it's a fine tune, we're guaranteed that we have a little bit more steerability in how we define things. And we have a recommended place to put in a bunch of these instructions. Whereas before, you're kind of writing a paragraph of how the data should look and then giving a couple of examples. So this is really helpful. The issue is when you have complex schemas, it's really hard to manage. So in this example, I have a thing called multi-search, which has a task properties, which is an array. And the items are referenced by a search object. And the type of the search object is actually referenced to the source type, which is an enum. And then you can see that the code here is kind of really hard to read. If I want to rename search into something else, I'm just doing string manipulation, and it becomes really unmanageable. And so this is where the first benefit of Pydantic comes in. It lets us define nested structures to make things more modular. It also handles the deserialization from the JSON, which means we get objects back out rather than a dictionary in Python. And more interestingly, because the doc strings and the descriptions are part of the JSON schema that it produces, the code itself is the prompt. Right? Lastly, because we have really helpful error messages in invalidation, these error messages can be used to re-ask the language model in case there's any issues. But from what I've experienced with the fine tunes, I haven't really run into too many issues around error validation. But if you were to do just JSON, you would be checking if names are in the keys of your dictionary. You would be checking that, like, if you got an age, that it's an integer or not a string. And those all things kind of add to more complexity in your code that's not needed. And then recently, for specific types like this, where you have a list of tasks, we can even introduce things like streaming, so we can get results sooner and have more benefits. And these can be all built into just how we model the data. Now, the modeling and the deserialization can be sort of co-located. And now, because this model, this OpenAI schema that we define is a Pydantic object, we can define methods, right? So we have really natural ways of extending the capabilities of our object. So in this case, our search class is a search method that says if it's a video, call this index. If it's a document, call a different index. And then the code that you write becomes really simple. If you don't want to have methods, you can just use regular functions. You can do the same thing. You can define a function that takes a query. The query has a source. You can compare the source type and then route things accordingly. And so now the execution and your schema and your prompt can be sort of contained in these class definitions. And this is a very normal way that we've all learned to program at some point. On top of that, because of the composability, you can have different extensions and inheritance. So for example, a user detail has a name and age. A user with an address just needs the address attribute. And then if you have user with friends, you can have like a best friend attribute and a friends attribute that all sort of self-reference each other. And GPT 3.5 and GPT 4 usually is capable of doing these kind of relationships quite well. And again, because it's code, you get nice things like autocomplete, type checking, and even just helps you figure out whether or not there's errors. And this all sort of contributes to just a much more seamless developer experience. So on top of just being easy for the user, it's actually really easy to integrate this Pydantic model into different tools. Mostly because Pydantic is one of the top 10 Python frameworks that, on the PyPy index. And what this means is a bunch of other tools also support Pydantic. So the two I'll highlight today are pretty cool for those who don't use Pydantic that much. The first one is Fast API, which basically allows you to make a web server really easily in Python. And one of the nice things they have is that they can auto-generate documentation and open API specs just by specifying the response model. So you see here that the response model is our schema again. So this is the response model kind of represents our prompt. And then when you define a function, let's call this call AI, that makes the open API call, parses it back out and returns a response model, we have this really nice line here, response model equals response model. And what that does is that it basically auto-populates all your documentation in the back end. If you're using another language model that can understand open API specs, it just means that automatically your language model can now communicate with any fast API endpoint. It's pretty useful. Another tool that I really like using with Pydantic is something called SQL model. So again, you can define a class, you can add the OpenAI schema that gives you all the language model capabilities, and then you can add the SQL model, which adds a bunch of SQL capabilities. So the same one object now can define both how you interact with the language model and get outputs back out, and create tables for you to do whatever other work that there is to be done. So in this case, I just defined 3 classes, Hero 1, Hero 2, Hero 3. But you can imagine that the language model is actually creating these classes. And then just like any other ORM, you can just create a session and then add those to your database. And now you have your schema, your prompt, your code, and your database and serialization all wrapped in a single object, which has its pros and cons. Another really nice tool I like to use with Pydantic is something called Pydantic, which again takes the same schema definition, but now can create diagrams that you can use to share with others, to improve your documentation, get alignment from other folks. And all these tools are based off of the Pydantic ecosystem. And so by using tools like the Open Function Calls, Pydantic, and the LlamaIndex Pydantic program, we kind of benefit from the entire ecosystem of tools that you would otherwise not have just by outputting JSON. Like this has been super useful, for example, because I have a web crawler that just extracts JSON out of this data, and now I can really easily create a database, in whatever database I want to interact with this data. And so this kind of goes back to my original point, which is that like the thing we're end up exporting is technically the prompt. It's a JSON object. But ultimately, the code is the prompt, right? Naming classes, naming the variables, and the documentation you provide as part of your code becomes the tool that we use to instruct the language model. And because we have deserialization, you get all these nice features for free. So I'm going to go over a couple of examples before I wrap up here. So let me see if I can just get started. I've been having an issue. Yeah, 1 second. So here's our full examples of how you can use Pydantic to do some of your deserialization and serialization, and more importantly, how to define the prompts in an effective way. So in this example, we're going to segment a request into multiple search queries and then execute them concurrently. So like in our example before, we first define an enum of the type of search we want to do, and then we define the search itself. And here, not only do I describe the schema, I also implement the execution. So in this way, it really is a function call. Then I can wrap it in another class. It just allows me to export multiple search objects and then start calling the completion API. And this pattern of creating multiple tasks is common enough in the production use cases that I've seen that I've built a helper class to do that for us. And this is what really supports sort of automatic prompt generation. It names things correctly, for example, and also supports things like streaming that allows us to yield individual searches. So the code is very simple. You just add these 2 lines here, and then you can do multi-search from response. You can have all type annotations that allow you to make your development a lot easier.
Sorry, could you explain that just a bit more? The streaming part, because that seemed pretty important, and I think a lot of people would be interested in seeing kind of what the significance of this is versus like kind of what you can do with normal prompts.
Yeah. So I'll go over after the example. So right now, what we do is when you call the segment, it's a blocking operation, which means we need to produce all n number of search queries before we can do anything, right? This is the same as sending a message to ChatGPT, seeing a blank screen, and then only seeing the response when the entire message is complete. And usually what that means is it feels like you're waiting for 5 or 10, 11 seconds before you get the response. But what OpenAI does is it does streaming. So even though the full message isn't finished, you start seeing the first character and the second character and the third character as soon as possible. So the feeling of latency is dramatically reduced. And so if we, for example, know that we're returning a list of objects, we should be able to do the same thing. We shouldn't return 10 objects when they're all finished. We should be able to return 1 at a time as quickly as possible. And so in practice, what we've noticed is, if you have to extract a lot of items from a single piece of data, the latency is effectively, like 1 over the number of objects you're returning, right? The first object usually returns in about 1.5 seconds, but if you have 30 objects, it might take 15 seconds. So the perceived latency really matters for applications when you're developing things, for example, for the front end. Yeah. But in this example, we wait for all the tasks to complete, and then we sort of execute them in parallel. And so you'll see the output here, just, those 2 documents. Another example I want to go over, which is a lot more sort of aspirational, is this idea of query planning. So if you guys have used React agents in the past, usually what it does is it will do one step, and then reason, okay, given this step, what is the next step I must complete in order to be able to answer this question, for example. But we could probably try to do that in one step. So here I define an even more complex schema. So first I define a query type that says, this is either a question that I can answer, or it's a question that requires multiple sub-questions to be merged for me to answer. Then I can define a query, which is the question itself, a list of its dependencies, and the query type. And then ultimately I can define the query plan. But what this definition gets us, though, is the ability to do something really interesting, which is to decompose questions in one shot. So in this example, the question I ask is, what is the difference in populations of Canada and Jason's home country? And the graph that you get is this very complex object, right? And so the first question is, calculate the difference in population between Jason's home country and Canada. We find that it has a dependency 2 and 3. 1 is to find the population of Canada, and 2 is to find the population of Jason's home country. And that is a dependency of 1, which is identified Jason's home country. So because we have this complete graph of the queries we need, we can sort of use all of our task planning algorithms to figure out what can be executed in parallel, how can you merge leaves together, and ultimately do a query plan in a much more efficient way. This is a single pass of the language model, rather than having a loop that may or may not finish in execution. So, if there's any other examples you guys want to go over, we can go over at the end of the presentation. But I think these two sort of capture like a simple and a little bit more complex use case for.
So this is very interesting because this actually inspired us to add a similar example within LlamaIndex, and it was very much inspired by this repo. Some follow-up questions here, because I think it's worth maybe diving into this just to understand a little bit more, both for us and also for the listeners. The thing about React is that when you ask one of these questions and it breaks down that question into a simpler question, when you say one step, it really means it executes like one task at a time, right? Whereas here, you're basically using Pydantic to represent an entire query plan. And that query plan could represent like an entire DAG of computation over your data. Are they necessarily mutually exclusive?
No, I think the reason why this is nice is because we can sort of specify the structure. Like if you were to specify the structure in a paragraph, for example, it's really hard to sort of have faith that it's going to be in a structure that we can actually export out. Like if I just said, like, give me a query plan in a nested JSON object, right? Like we really don't know what's going to come out. But because we know that these language models are fine-tuned to sort of be a little bit more precise, if you have a model that has the ability to reason, doing structures like this become a lot easier. The real nice thing is that because of this manner, we can actually execute things in parallel, right? So for example, right now, to compute number 1 and I think number 2, we could do that in the same time, right? In the React model, we don't necessarily know, like we would have to implement that specifically for the React model. Whereas here, we can just do some kind of like, topological sort of this tree and then sort of execute in parallel wherever we can. So I think we're going to get a bunch of different performance wins just because we can do this.
Yeah, definitely. I think Lewis linked relatively like a similar paper in the chat called FreeWoo. This also reminds me of another paper called searching, which is basically interleaving kind of like query planning as well as like some sort of like sequential reasoning. And so if you blend this with, for instance, like a React agent, then you could basically have like sequential refinement of your query plan over time, technically speaking. How well does this work?
Yeah, so I really haven't had sort of a data set to sort of execute this at scale, mostly because a lot of the problems that we want to run in production end up having to be way less ambitious, right? Like usually you want to have your agents have like a single feet of strength that can work well. So I really haven't had like a time to evaluate whether or not this works on, for example, like a Marco data set that performs in a really well manner.
No worries. Yeah, no, it's very interesting though. So you have these two examples. I think one thing that's interesting is, you're basically using Pydantic along with the function API for kind of like this goal of like structured data extraction. It turns out you can use this for query planning too. You had another example I remember that is basically kind of using Pydantic as a way of like sanitizing like SQL inputs. Do you have that pulled up?
Oh, I don't have that in code. I have that in the GitHub. I can go
Oh,
over
no
that. Yeah. How are we on time, by the way?
Oh, we're good. I mean, this is all flexible. This is by the way, like for everyone in the audience, if you have any questions, I think for the last like 15 minutes or so, we're happy to do basically Q&A, and if there's no questions, I can just keep on asking questions or going through examples. I think there's a lot of cool stuff in here, and so I think it's honestly we could have like over an hour of content just by looking at some of the examples.
Oh, cool. Great. So yeah, I'll go over the SQL example. Maybe the diagram actually is good to share. So in this example, what we have is, so let's take a step back. So everyone is sort of worried about having just like SQL injections, right? You can sort of do this like interesting string formatting, and if you do, and then if your actual code that calls a SQL is done poorly, you sort of become susceptible to SQL injections. And so there are best practices of how we can call that SQL. And usually what it is you have sort of query parameters that are formatted by the SQL engine rather than a SQL string being formatted by the user that is then sent to the query engine. So the idea is that we have a SQL template, we have the parameters, and then the parameters have keys and values, right? So for example, the name is going to be some username, et cetera, et cetera. And then one thing I added that's kind of cute is just whether or not we think it's dangerous. This is cute, but it's not really necessarily a thing that will sort of keep you safe for sure. So again, we have a SQL template type, which is a literal or an identifier. The difference would be like an identifier is like a table name, whereas a literal will just be a string. And then you can do things like this, where a query will be templated by the ID, and then you will actually output the parameters separately. And then we can sort of sanitize that as well. So you have SQL, you have the query template, the query parameters, whether or not we think it's a SQL injection. And then if we actually run the code, you see that we'll actually generate code that uses templating correctly, and then the arguments for that function. And one of the cute things I did was I said, you know what, like if I say, give me the name for a SQL injection, we'll do this templating and then warn you that the SQL is risky. But the idea here, again, is like, if we know what we want, we can try to model that more concretely with Pydantic rather than sort of just in text describing exactly what we want, which it gives us unclear direction as to where the instruction should go for the most durability.
Awesome. Cool. Thanks for the example. Maybe taking a pause here and just taking one question from the audience. So like how kind of like portable are these lessons to like other languages? Like basically if you wanted to do all this cool stuff and you're kind of promoting these principles of like schema engineering, right now it's very much like Python only. So how does some of those like carry over to stuff like TypeScript and other languages too?
Yeah, so Microsoft actually came out with something called Type Chat a few days ago, actually, maybe like a week ago. And so Type Chat is effectively just using plain TypeScript interfaces to do this prompt engineering. There's also sort of less documented versions of it in Go and in Rust, built by some friends of ours. And I can share those in the docs below. They just don't have much documentation, so I haven't been able to sort of feel good about just like sharing a repo with no README, but there are some implementations in Rust and Go as well. Because the general idea is that, in reality, a lot more programming languages have a definition of a struct. And in fact, Python has to use Pydantic because it lacks one, right? So you can imagine like C has struct. So you can imagine dynamically creating your JSON schema using like a C struct or a Java class interface, for example. So I would say this pattern is pretty well supported by most languages. Interestingly enough, what I think OpenAI actually does is they actually take the JSON schema and convert that to a TypeScript interface. That way, it's a little bit more prompt token efficient. So I think even in the actual system messages, they're actually going to be TypeScript interfaces rather than the actual JSON schema in the object. And it's the TypeScript is much more efficient.
Yeah, that was another point I was going to bring up is like, I think for the human, they're programming with all these objects in Pydantic, but what the OpenAI Function API sees is the JSON representation of Pydantic, which kind of has its own structure, right? And so I wonder if like kind of the specific form of serialization might actually affect performance, like whether you're kind of like exposing like a certain like the Pydantic structure or like maybe like a simpler list of arguments.
Yeah, I think right now they use TypeScript, but just given that I think there's more Python data in the training data and less TypeScript, like without fine tuning, I think I'm actually convinced that Pydantic copy pasted in the system message would do as well as TypeScript in the system message. But so far I've been using TypeScript because you can do inline nesting, which is, I can talk about that later.
Sweet, no worries. And maybe just one more question. I know you have a few slides left. Have you experimented with streaming? This is a question from the audience. Have you experimented with like streaming the structured data? JSON is often like a non-streaming format. You need the whole string to make sense of it, but there's alternatives like JSON-L that kind of split that difference. I mean, I think you've talked a little bit about streaming with respect to kind of like Pydantic objects, but curious to your thoughts on this.
Yeah, so in this example, let me go back to the code actually. So if you look at the citation with extraction example, what we use is we just use streaming the same way that OpenAI uses streaming, which is the server sent events. And so, yeah, so here we see that instead of doing from response, we do answers dot from streaming response. And then in the actual code, what we do is this. We say, let's create a JSON object that has the body, the spans, and the citation. And then what streaming does is actually you serialize that into a string, and then you return it as a data attribute. Right. And then the client will read that data attribute, and then extract out the JSON, reserialize it on like the TypeScript side, and then render that. Yeah, so it's just basically done through server-side events, and this is kind of like a canonical example of how to do that. Yeah, you just need to go to the examples, citation with extraction, main.py, and this is a fast API app, so it's actually pretty straightforward to set up.
Awesome. Okay, well, thanks for the answers, and I know you have a few more slides, and maybe go through those.
No worries. Well, yeah, just 2 slides. Yeah, so I think the general learnings for me is that actually I think prompt engineering is here to stay. Like this doesn't actually replace prompt engineering. It replaces prompt engineering in the sense of I think we're going to move away from walls of text, because the wall of text tries to over specify the schema that we want. But the JSON schema actually does quite well. But it actually is very important to have really good wording, structure, and reflection in the way that you've designed your schemas, right? Like there are features where if I name a variable incorrectly or poorly or is very ambiguous, the entire task is basically not feasible, right? Like in the example with the query planning, I first had the type called merge, and it basically would never work. It would never correctly determine that it was like a merge questions. But if I just had renamed merge to merge multiple questions, now I had like 100% success rate on the 10 examples I tried. And so like this naming becomes like crucial. The other thing I kind of realized though is that once you just define structures, we're kind of migrating back from just plain text to structured data. And the patterns we have for writing functions and structs goes all the way back to sort of like C code. And what this means is that like how we manage language models really is just how we manage code in general, and there's no magic around that. I would also say that one thing I've realized is that like every time I've had hallucinations that result in invalid data, it's been a feature and not a bug. And for the most part, I consider that feedback on the schema that I built. So usually if they're giving me the wrong type of data, I actually change the schema to fit that data, because usually I find that the proposed schema that GPT-4 has given me is actually probably a lot better. And then just lastly, I think function calls are not limited to OpenAI, and JSON output can be done by all these other models based on different prompting tricks. And so I think in the open source community, we'll catch up pretty soon in being able to support this kind of API. And then I'll sort of share a little bit about some of the things I've been exploring. And if anyone is interested in playing around as well, just feel free to DM me on Twitter, and we can chat about some of these ideas. So the first one is something that we actually already did, which is streaming outputs, right? Like if we know that the schema is going to be a list of objects, like that's a very obvious time when we know we can probably stream something now. Like if it's 2 lists of objects, it's hard to figure out what exactly we're doing here, but for a single iterator of a certain schema, well-defined. I think I also want to borrow some ideas from Marvin's AI application API, which allows streaming in inputs. So the idea is like you can define a schema, pass that into this helper function, and now you get an API that is the CRUD application of this schema, right? So if I give it a user, the interaction is not return a user. It's going to be update user, patch user, like upsert, create new, and delete. And this would mean that we can basically build applications where we scan over large documents to build up the state of our schema. And so this would allow us to do a lot more like streaming data extraction. I think would be really good for managing large documents. I'm also working on generating an open source data set for function calling. Literally an hour ago, I found a data set on Hugging Face that does something similar. So I think I might reach out to them. But the general idea here is, I think the open source community ought to just build one, so we don't become reliant on the OpenAI spec. And then on top of these schemas, one thing that's really cool that I want to explore more about is right now our eval systems usually show you a string on the left, a string on the right, and the string on the left is the prompt, and the string on the right is the completion. But if we know the schema coming in, we can actually define like custom dynamic interfaces that allow us to sort of correct the schema as we go. So for example, if we know that the search response has an enum for the type, we should be able to view the type as a drop-down menu. So if we think the language model did an incorrect completion, we should be able to have a drop-down menu say, like it wasn't an email, it was a document instead. And because we, for example, know that multi-search is a list of schema, there should be a like add search button. But once you add it, you have this form that you can fill out to add more data into your evals. And then you can do sort of evaluations on specific attributes rather than evaluations on the entire text. So it allows us to modularize the different ways that we can, look at performance, right? Maybe it scores well because we know there were 3 search queries and we've returned 3 objects. And so that metric is good, but maybe the search query itself could have been written better, and you can sort of give feedback at these specific pieces of the schema rather than the output as a whole. So these are some ideas I've been playing around with. And then lastly,
that's really interesting, actually. Sorry, just jumping in, because I think one of the issues with just pure text-based eval is it's very unconstrained, and so most people these days just try to probably like hack together some LLM-based eval solution with like GPT-4 to just like evaluate the entire text blob against like some ground truth or against a query. So if you can actually kind of decompose this output into like some sort of structure that, for instance, like has a list of variables, like int, floats, like smaller strings, it's a lot easier probably to define like task-specific heuristics for each field.
Yeah, I think this would make, and it also means we have now a family evaluation, right? Like if in this multi-search task, one eval is just, did I get the number of searches right? Like there were 2, we got 3, right? Another one is like, did we get the number of searches right? And did we get the search types correct? Like maybe the search query is correct, but I searched the videos database and not the email database. And there should be some flexibility on like how we're thinking about these things and building data sets from there. Yeah, I think it's a big idea. I just don't know if anyone's thinking about that right now, but it's also hard to define arbitrary UI, like evaluation UI based on the JSON schema. But the schema is there, so it contains everything we need to be able to build something, right? Like if it's an array, we know there's going to be a list element with like add and subtract. If it's an enum, we know there should be a drop-down menu. If it's a float, there should be like a slider. So there's some language we have around doing these kind of like generative UIs. Yeah. And then lastly, with self-hosting.
Oh, sorry. One more. This is a really dumb question. I think both these previous two bullet points were under the section called fine tuning. What does fine tuning have to do with this?
Right. So the idea is like at some point we want to make the model better, right? Mm-hmm. And in order for us to do that, we need to sort of make sure that the data we put in is good. So for example, if we have like a Llama 7B model producing these JSON objects, it'd be nice to build a UI that says, let me look at the data, look at this like evaluation. Oh, I could have added more detail in the search query. This was an email and not a document. I would be like to be able to export that and then put that back in the fine tuning.
Got it. Makes sense.
And then, you know, for things like whether or not it had 2 search queries or 3 search queries, like that can be effectively our reinforcement learning, right? Like we're not penalizing against the text in the search query necessarily, but we are saying, you know, if one example generated 3 and one of them generated 2, and we know there's 3, there is a preference that we can move the language model towards. And maybe we're moving towards more search queries or less, or, you know, the way that the queries are phrased. And so this all kind of goes back into the fine tuning of an external model. Yeah. Yeah, and the last thing, just self-hosting, which is, you know, at some scale, maybe it doesn't make sense to do OpenAI. You know, how can we have the best practices to self-host our models to do this kind of structured extraction, which is very different because you can imagine, like right now, a lot of our APIs are like batch size 1 because we assume we have like a single completion that we want. But really, you know, if I have 1,000 documents that I want to extract like named entities out of, like there's no reason I shouldn't be able to like load up a big GPU and just have like batch size like 64, and they all generate JSON back out, and then we can be a little bit more efficient with how we're using these models. Yeah. Oh yeah, and then the last one, which is just like, I think right now, constraint sampling and JSON former doesn't have good implementation that scale well with batching yet. So those are some other ways to explore that problem. Yeah. Sweet, that's the last slide. Yeah. And here's some resources for anyone who's interested. I'll share the slide link near the end.
Yeah, and if you guys don't follow Jason on Twitter, memorize his Twitter handle right there. He posts stuff pretty much daily. So, and a lot of it is like insights on this stuff. And so yeah, definitely give him a sub. Cool, awesome. Jason, thanks so much for the amazing content. We'll try to go through some of the questions from the audience and then maybe come up with some of my own, because I think there's like a lot to unpack and a lot to kind of ask about. Let's see, I think one of the questions that the audience asked is, so I think Chase asked, are the descriptions you provided in the field of the model attributes, like say for each attribute in a Pydantic object, are they actually provided formatted in the JSON string that's provided to the OpenAI model? Like what does that look like?
Every time I do this, let's just do the introduction. Yeah, so so like, for example, here, the doc string of a class is added as the description. And then the description of the name is the description of the name property. And it will preserve formatting in the sense that, like, if you have like double new lines and then a tab, like it will preserve that in this description, if that's what you mean.
Yeah, that makes sense. So it's basically just like translated into this overall JSON spec that is fed into the input of the LLM API. So Alex asked in terms of, well, I think this is just like a general question, but like I wonder if there's benchmarks of using functions versus like coercing structured outputs with prompts. I think that'd be pretty interesting to measure, and I'm curious to get your take on this, Jason.
Yeah, so I think a lot of this comes down to the fact that if we don't have a fine-tuning data set of labeled data, we don't actually have access to a benchmark. Or like we could, for example, just test, if I just have a sentence description plus an example, can I just use the markdown trick and get the output? Because we don't have like a public fine-tuning data set, it also means we don't have a public evaluation data set. Because if we did, then we would do a fine-tune. That's kind of one of the goals I'm working towards, is not only just do we have a benchmark for is the output correct, it's more than that, right? It's like, is it following the descriptions well? Like, is it steerable? When there are multiple schemas, is it selecting the right schema? And then to add to that, not many schemas are in the shape of like this multitask that I talked about, where like it's a search as a task with a list of searches. Like, what's the evaluation there, right? Is it a number of searches? Is it like it becomes really tricky to define like what a good benchmark is. And so again, that's the goal there is once we have that data set, we can have benchmarks of just how often are keys hallucinated, how often do we have misformatted JSON, which are separate from are the arguments good? Right? So there's a lot of open, I think, research that can be done here.
Yeah, I mean, I guess besides the benchmark itself, in terms of understanding the difference in performance between just this idea of using a text completion endpoint versus like the function API, I do think it's an interesting question to wonder, like, the function API is a bit more constrained in the fact that it's specifically designed around kind of you provide it a set of like functions or like Pydantic schemas, and then it can like the LLM API will basically output like whether or not it picks one of these functions. Whereas I think if you're responsible for kind of like coercing this output with the prompt, the UX is a lot less constrained. And so, there actually could be like a right answer in there, but you as a user would be responsible for actually figuring out the right prompt to coerce the model, right? And so I do wonder if there's like a UX question here where it's just like by virtue of LLMs actually offering this type of more constrained API, it's actually easier to do this type of stuff like extracting structured outputs.
Yeah, and I'm going to call out one thing here, which you'll notice that like, if you look at all of my prompts, the biggest piece of alpha I've realized is just adding the word correctly in every doc string. Like the amount of times someone is like DM me and it's like, hey, I tried this example, it didn't work. And then I just looked at the prompt. I'm like, well, you copied the code, but you didn't add correctly. And so even these small things are things that we shouldn't really have to add as a developer, but are things that we do end up having to do to improve the performance. So a lot of it is like, how much of it is our own inability to write good descriptions versus a limitation of the model.
Sweet. And speaking of which, I know you had an entire like tweet thread or thoughts on this. Any other kind of like tips and tricks for users that are playing around with the function API that you have found helpful? One is just saying correctly everywhere.
Yeah. I think another one that is probably really relevant is, for a long time, I just wanted to sort of show off its capabilities by doing a lot of recursive definitions. So in this example, I define a file system, but the interesting thing here is that for any node, the children can be a list of nodes. And what this means is I can generate like a very deeply nested JSON object. And so that's kind of cool because it means the language model can attend to like all the closing brackets and all this stuff. And while it worked pretty well, you find that as you do more complex examples, it's actually much easier to go down the path of having a flatter structure. So, I could have defined a query to have children, which is a list of queries, but by defining this dependency array, like I had much higher success in being able to actually parse the data back out. And the reason I ended up doing this was because at some point, GPT-4 would only return a flat array with dependencies rather than the nested structure. And at some point I thought, you know what? I think it's right. I think flat is better than nested. And that's kind of like a good reminder that like that often will be the case. Like having a flatter structure definitely makes a big difference. And being careful with variable names, as I've found, made a huge difference. So I can go over an example actually where I have this question answer schema. And when I was testing it, I asked it to return both the question and an answer as a list of facts, right? And when I did that, I had really, really good results. So for example, when I asked like, what did the author do in college? The response would be like, the author studied this, the author studied that. In production, I copied the same API, but I didn't include questions. I didn't include this attribute because I thought like I didn't need to, because the only reason I did that was just to make my review a little bit better. And what I found was by removing this question attribute, the tone of the answer changed completely, right? And the reason was because the tone of these answers became more like statements rather than the answer to a question. And I think that was because the variable name was called fact, right? And so by like, even though I don't use the question, having this attribute here changes the nature of my answer. And so it's also important to realize that like these descriptions, like this docstring, this description, and this description, and the variable names all sort of interact together, because again, it still ends up being text completion in the end. And so just being aware of this interaction is pretty useful. And then another thing, I guess, the last thing I would say is chain of thought is still very valuable here. So if you have very difficult tasks, it might be worth doing a chain of thought step before doing this extraction, just to prepare the data in a more reasonable way, because I think, every token is an additional piece of compute. And if you need to have if you have a harder time doing this extraction, give it more time to think.
That's these are all very useful tips. Maybe one last question that I'm personally just very curious about. So how do you think about like how like prompt engineering, prompt development will evolve with this new idea of like schema engineering? Maybe kind of like more specifically, I'm kind of thinking specifically about like prompt versioning. So if everything's in strings and you want to experiment with like different prompts, then you can kind of like, play around with like different strings and, have an idea associated with each string and maybe like register that somewhere. I think here, how do you think about like, even given the tips and tricks that you just said, like the idea of playing around with like different doc strings, like attributes of the Pydantic object, and kind of like trying out different variants of the same thing, so that you can basically see which one has the optimal performance? Would you just create like a separate copy of different classes? Like how do you do that?
Yeah, so I guess there's like a couple of things, right? Like one dumb thing you can just do, for example, is just like do inheritance plus some overloading. So you can have like fact and then fact v1, fact v2. The other thing I think about a lot, and mostly because I don't do a lot of live experiments, is I just use version control. Right? Like I'll just make a branch. I have my fact class with a different bunch of descriptions. And usually what I do in all of my sort of like prompt ops tools is I just save the git commit as another attribute of this like logging. And so usually I just sort of split on different git commits rather than trying to version the fact itself. That might not be like a satisfactory answer, but that is what I have been doing.
Yeah, I think maybe one just thing off the top of my head, because right now you have like the doc strings as well, which is part of the prompt, which is kind of at the class level. But if somehow you can make stuff at the object level, then like different variants could just be like different objects of like the same class. So maybe like almost a generator of some sort that could like, maybe create like different variants of Pydantic.
Yeah, so let me do something really disgusting and show people like what a meta class is real quick. So in Pydantic, there are functions that let you construct classes, right? So like I'll show an example, which is pretty not super crazy, but a little weird, which is multitask is actually a function which takes in a class, a name, and a description. And then I call this create model function that has like this is really confusing to read actually, but so basically take a look at this code right here. So first I define the name of my class, which is going to be multi and then the task name. And then I define a single field called like list task, which basically says this is the type hint and this is the field. Like it's no different than just saying like class multi search list tasks colon list up, right? And then you can call this function create model that creates a new class. And then I just sort of set the doc string to be the correct segmentation of blank task. So like if you want to go crazy, like you could define like this schema, have like a JSON config of like all the names and docs. But you know, I would say this is like kind of advanced. Like, it's funny enough, GPT-4 is so aligned that if you ask GPT-4 to write code like this, it'll suggest you write simpler code. Like you'll say, like, I don't think this is like the best use of like meta classes, but like if you want to get crazy, like you can do things like dynamically create sort of an array of prompts. But I would say for most people, it would probably be overkill. Like it might make more sense just to copy paste the code.
Yeah, makes sense. In any case, thoughts for the future. Cool. I know we're a little bit over time, but I just want to, thanks, Jason, for the time and the amazing presentation. And I'm sure the audience and I have both learned a lot. And so, so the Zoom room was actually capped at 100, which I didn't realize. And so I think a lot of people actually weren't able to join. So this meeting is recorded, and I'll make sure I'll post this on YouTube right after and kind of share your insights and thoughts with the rest of the world. All right. Thanks so much. Have a great Friday.
Take care, everyone.
Thank you.
Comments too.